So first things first, we need to draw a diagram. Again, on the final, it's possible that you get a picture and it says identify which of these is correct. But more than that, you want the diagram to help you solve the problem, because the problems are kind of tricky if you don't. So we have a bus going north. The bus has a mass of 700, so I'm just going to write 700 on the object. Going north, and its velocity going north is 43. Then we have a beetle going east, 570. And its velocity is 62. Then it says they stick together, and they're going to go off at some angle. We don't know what that is, so I just draw the arrow for it. Okay, I've drawn the diagram, so now I need to set it up. Now, there's two ways to solve this problem. I don't care which way you solve the problem. I just want you to get the right answer. I'm only going to show you one way because it would take forever if I was going to show you both. If you do it the other way and you want me to double check your work, I'm more than happy to do that. So let me know if that's something that you need if you're doing it a separate way. The thing to keep in mind is that there has to be a beginning and an ending x velocity and a beginning and an ending y velocity, and then some combined resultant velocity. So we'll call this v, we'll call this vx, and we'll call this vy. So there's some x velocity forward, some y velocity up and down, and then some angled velocity. So the equation we're going to use is conservation of momentum, because these are two objects colliding together and sticking. That's a momentum thing. So the momentum of object 1 initial plus the momentum of object 2 initial equals the momentum of object 1 final plus the momentum of object 2 final. So we're going to do that equation and set it up. Pretty straightforward. Here's where you have to be careful. There is an x direction and a y direction, which means we can't do them at the same time. Okay? We have to do them separately. So I'm going to set up an x equation and set up a y equation. The x equation is going to look like this. The initial of 1 in the x plus the initial of 2 in the x equals the final of 1 in the x plus the final of 2 in the x. So the initial of 1 in the x is, I'm going to go ahead and use Ringo's car to the east as 1. It doesn't matter which is 1, doesn't matter which is 2. Okay? So momentum, P equals mv. Okay? So mass times velocity, 570 times 62. Now I look at object 2, the bus. All right, is that in the x direction? No, that one's up and down. So the x momentum initial of object 2 is 0. There is no x momentum of object 2. Then I do the final. Well, they stick together. So that means, do both of them have an x? Yes, because both of them are going forward after the collision. How much forward, we don't know, but they're both going forward. So that means instead of having a P1 plus P2, we're going to have just a P12 because they stick together. So the mass is not 570, it's not 700. The mass is 570 plus 700. And then that's times v final in the x direction. That's how the setup works. So I figure out what's the x momentum for both objects beforehand. In this case, it was just the car, not the bus. Okay? Then, after the collision, they stick together, so I add their masses together, and there's just one velocity because they're stuck together as one object. So now I'm ready to solve the math here. So 570 times 62, 35,340. 570 plus 700 is 1270. God bless you. And I really don't need the zero here anymore. Divide both sides by 1270. That's the opposite of multiplying. So it's being multiplied by Vx, so the opposite is dividing. $27.8. We're not done yet. We need to do the exact same thing for the y direction. So I'm going to go ahead and do that now. Okay, what's the car's vertical motion before the collision? None. Okay, what's the bus's vertical motion? Okay, P equals mv. 700 times 43. After the collision, they stick together in the y direction, so they add the masses together, 1270. And it's the y velocity now that I'm looking for. Okay, and that gives me a y velocity of 23.7. Okay, I'm not done yet, but I'm close now. Now, all that's left to do is to figure out the total velocity. So I have x and y, or I have a and b as my sides of my triangle. I need to find c, the resultant vector. So that's going to be Pythagorean theorem. A squared plus b squared equals c squared. So a is my x value, 27.8 squared, plus b, which is my y value, which is 23.7 squared, equals c squared. So 27.8 squared $774.3 and 23.7 squared $561.7. So add those two numbers together. Yes, sir.
Not that it would have changed a bunch, but wouldn't the 27.8 squared equal 772?
It depends on how you rounded or didn't round. I did not round my number. So if you rounded, you're done. So 27.8 probably is, but I use 27.83497 or whatever it is. It's not a big deal. 1336.0 equals c squared. Square root both sides, get just c by itself. C is 36.55. Okay, so we figured out the velocity. We're not quite done yet. We're very, very, very close. It says find the magnitude and direction. Magnitude is the number, direction is the angle. So we got to find this angle here. And finding the angle is very straightforward. You're using tangent. So tangent theta equals b over a. The b value is your up and down value, which is 23.7. Your a value is your side-to-side value, which is your 27.8. Notice I'm using after numbers, not before numbers. So 23.7 divided by 27.8 gives me tangent theta equals 0.85. Now, I don't want tangent of theta, I want just theta. I got to do the opposite of taking the tangent, which is the tan -1 button on your calculator. So when I do that, I get 40.4 degrees.